Thank you for the introduction. I hope I can live up with a fresh image for the rest of the day. Yes, I'm here to basically explain to you our learnings from participation to the road test with our Pampers case study. And what I will be talking about is, first of all, of course, explain to you what we learned, and then also tell you about our position on carbon footprint from Procter & Gamble and the challenges that we see, because I think the two previous presentations were from people upstream in the supply chain. We are a little bit down because the next stage after us is consumers and some retailers. So I think that's providing some interesting perspective. Well, I have one slide about our company. We are a multinational company. It's a US company employing 127,000 people around the world. And our mission is actually touching and improving the lives of billions of consumers. The number of brands that we sell is more than 300. It's in more than 180 countries. And 22 of them have an overall NOS of more than $1 billion. The total annual sales is $79 billion, which is getting close to some countries' gross domestic product. And our company is actually 173 years old. That's a calculation mistake now. Which can give you where you can imagine that we have well-established governance systems within the company. Now, where we started from, and I think Andrea gave a very interesting perspective just before the break, is when this product protocol was developed, it started from the LCA standard ISO 14040, 14044, and that's exactly where we started from participating to this study. So we had an existing life cycle study on Pampers, which was cradle to grave, and it happened to have climate change in the list of indicators. So what we were interested is, from taking this protocol and compare to how we did the life cycle study and see, what are the differences, how much do we need to change to make it compliant to this protocol. So we really looked into the choices on system boundaries, functional unit allocation, data selection, basically all the chapters within the protocol. And here are our key learnings. Actually, the completion within 6 months of this assessment would not have been possible without having the life cycle study available. Again, data collection is, I think, the primary burden that we are running into, and so 6 months is extremely short to gather all the data. The good news, I think, is that in terms of choices around scope, allocation, functional unit, we basically didn't have to do any adaptations. But on the end-of-life modeling of, in this case, a diaper, we could have actually received better guidance on how to deal with things like energy recovery from incineration practices, or, for example, landfill gas collection, because those credits, it's basically an allocation choice, and that can make really a difference when you do a calculation of a study. The other thing is that, well, I think the good thing in the protocol is that the chapter on the data quality assessment basically learned us that 21% of our total score has a quality D, which is fair, I would say. And that is to do essentially with the general models that exist for looking at end of life with your materials. So what happens in an incinerator, what happens with your product when it's in a landfill. And to that end, we are actually working on a landfill model, for example, where we look at the biodegradability, how much the biodegradability really leads to greenhouse gas emissions. So there is really work coming forward from that step. The other challenge, I think, from the many discussions we've had on this thing is the inclusion of capital goods. The system that we use, SimaPro, allows us to very easily exclude or include that, and so the difference that we saw is 4% when you include or not include it. But we couldn't do that assessment, take it up to its full assessment because, again, time was a limitation. But we estimate that it's not going to be larger than 5%. And then I think in terms of practical application, taking this calculation, what you do with it, it becomes difficult because until data availability becomes better and more routine practice, before you have finished the calculation, 1 year is gone like that. So a 2 years time frame for redoing a calculation doesn't seem very practical in our opinion. And also in the very first drafts, there was a measure that said that if you report a number, then the next time you should report a reduction. In terms of innovation cycles with our products, that's an extremely short time frame. Again, keeping in mind that data collection is a major roadblock to do these things very fast. So this table is a kind of summary of how well we comply with the protocol. I think on most of the chapters, if I can call it like that, we are very much in line with the protocol. On the boundary systems, as we said, we did not include the capital goods for our LCA assessment. We did it, and we saw it made a small difference. On data quality and uncertainty, the end of life is a little bit more uncertain, which we also know from our LCA study. And then in terms of assurance and reporting, we actually didn't go through those steps because we had already an ISO study validated, so we didn't feel the need to do another assurance step. And also in terms of reporting, we have the ISO LCA report, so we didn't go through the necessary steps of the reporting as listed in the protocol. Now, that gets me actually to where we think, where's the value about doing carbon footprint calculations. As a company, we're really committed to reducing energy and carbon in the supply chain. So we actually last month had our new corporate sustainability vision announced, where we have targets on our own operations. We will, in the longer term, have 100% renewable energy, and we will also use more renewable materials in the future. So I think both of these elements will actually contribute to lower energy use and carbon in the future. We also support very much the development of standardized methods. I mean, for an international company, it's very important that you have these standardized methods available. And so we've been involved in many of the processes going on in this field. But at the same time, we think it's premature to introduce carbon labels. It has been said already in previous presentations, the methods and the standards as they are today are not sufficiently well describing how, to take out the uncertainty, to meaningfully communicate to consumers, what your number is worth, what the uncertainty is there. And for that, I have a couple of very practical examples. This one is actually a case study on a laundry detergent where we compared the 4 red bars. There are 4 different forms of laundry products. So you have a powder, you have a compact liquid, you have a liquid pouch. So all of these we calculated carbon footprints for, and we just expressed them relative to the largest one. The question is, is there really a difference between these carbon footprints? And as you can see from the uncertainty bars, probably there's not so much of a difference. Now, what's more important, all of these calculations were done under a very well-defined set of conditions. If you then would go to the first blue bar, is where you take one of these forms, the last one actually, the compact liquid, which is used in the UK at 40 degrees, and you basically assume what it would be if you would use your product at 30 degrees. you see a significant decrease, much bigger than the uncertainty which exists amongst the 4 products. And then the next step is if you would use that same product in France at 40 degrees, just because they have such a high nuclear power percentage in their electricity grid, that number decreases even further. So there's a lot of elements within your model exactly that define how your carbon footprint looks like. So another study that we did around carbon footprints is actually to understand, what are the significant differences? When are numbers really becoming statistically significant? So what we did is we looked at 3 different types of assessments. In the first case, we have one producer that actually compares their own 2 products. And so essentially all the choices that you have to make within your model are fixed and consistently chosen. In the second assessment, we look at how the situation for exactly the same products would look like if you have third parties comparing the same 2 products. In the first case, you would have the same standard method, for example, the IPCC method for looking at your carbon footprint. And in the second case, your boundaries and your scope are completely free, but still, up to the level where ISO allows you to make choices. And so this is exactly what you will find out. In the first case, on the left side, there is, where you have these very controlled systems, you can really see a very narrow spread around your carbon footprint number. And that basically allows you to make internal choices around, how do I have to improve my products? In the second case, where you do have a third party doing that same type of assessment, the average number doesn't change, but the spread around your carbon footprint becomes much larger, such that, they start to overlap. So, there is some uncertainty in making a choice between 1 or 2 products. And in the third set of comparison, essentially that width around your average becomes even larger, so that it becomes highly uncertain whether really one product is better than the other. So imagine that this goes on your product. I mean, people may have the impression that they do a good purchase decision, but in fact there is quite an uncertainty associated with it. So in the first case, I would say we have an apple-to-apple comparison. In the second case, you have an apple-to-coconut comparison. And that brings me up to the level of communicating carbon footprint results. As I mentioned in the previous example, uncertainties are certainly not easy to communicate. But the important element is also that those elements in a product life cycle, which really where the consumer can have a high impact, it's not communicated by a single number. And we believe, that's the area where if you want to move into a lower carbon energy, that's the part where in terms of communication, people need to be aware about. The other thing is also that carbon footprint is a narrow view on the whole environmental aspects around your product. So in terms of downsides which are seen in other areas, it doesn't look at it. So the way we LCA in general would look at a broader set of indicators and allows you to make more informed decisions. So that brings me to my conclusions. Procter & Gamble is very much supportive of standardized protocols. That's very clear. Our participation to the road test showed that there was good agreement between LCA-derived carbon footprint numbers and those that you would obtain from the WRI protocol. But at the same time, when we didn't have our LCA study on Pampas, we could not have completed the road test within the 6-month time frame. And the key challenges that we see for carbon footprint are that the data are uncertain, the communication is a real challenge, and it's another view on the environmental aspects of products. And so for the above reasons, we believe that it is a bit premature now to start thinking about carbon labels. And with that, I will be happy to answer questions.